All right, Newton's method of linearization. I did differentials as another video, so if you want to watch that, you feel free to. Newton's method of linearization is another way to attack finding the square root of 24. It's weird, and we end up doing the exact same math in both of these and getting the same answer. With this method of linearization, we sometimes do multiple iterations. But in this case, we can only do one since we don't have a calculator. So I want to approximate the square root of 24 using Newton's method. So what I'm going to do is take y equals x squared minus 24, and I'm going to approximate the zeros of it. The zero is of this function is if I make this equal to 0. And notice if I solve it with y equal to 0, we're going to get x squared equals 24, which is x equals root 24, which is that number right there. So that's why that's why I come up with this equation, because its 0 is the solution to that guy. Okay, so I start by finding y prime. Basically, Newton's method of linearization uses tangent lines. So I need to find y prime, and I need to find the value of y close by as well. So y prime is equal to 2x in this case. Newton's method of linearization always starts with a guess. I know that x squared minus 24 is going to hit close. It's going to go like this, right? It's a parabola, that it's going to be somewhere between 4 and 5. And since root 24 is so close to root 25, I know it's actually going to be closer to the 5. So if I had, for example, 17, which is closer to 16, then I would take the 4 as my guess. So I need to have a guess for what the 0 is. I'm going to guess that this 0 right here is close to 5. X equals 5 is my guess. And I know that because root 24 is approximately root 25, which is equal to 5. I'm also going to find the y value of this thing at 5. So y of 5 is equal to 5 squared, which is 25, minus 24, which is, wait a second, which is 1, right? Yeah, y of 5 is 1. And y prime of 5 is another thing, so that's why I found y prime is equal to 2 times 5, which is 10. So you may be like, well, why do I find all these numbers? Well, this right here in my point slope form is my x sub 1. What I'm doing is I'm making a line that, taking this thing at 5 and I'm making a tangent line that comes down to that 0. So that's my x1. This is my y1. And this is my slope, so it's my m. So what I get is that, I'll write out y1 minus, or y minus y1 equals m times x minus x1. So now I just plug these pink numbers in. So I get y minus this guy. So 1 equals m, which is that guy, 10 times x minus that guy, 5. So from here I need to solve. So keep in mind I have a tangent line. This is the equation of that tangent line. I got it from a point up here. It's actually kind of a bad picture. Okay, so I've changed my picture here a little bit to help you see what's going on. So what I have was this little curve right here is that guy. I know it hits at root 24. I know 5 is close because that's root 25, right? So what I did was I found this point right here, which was this x1, so that's 5. Notice it's directly above the 5, comma y1, which is 1. Now what I'm going to do, what I did was I found the equation of this tangent line like this. So, and because I took the slope of the blue line, which is this guy, at that point right here. So what the Newton's method of linearization does is it looks at where this dotted line hits right there. Because I took a good guess of 5, but if I take the tangent line at 5 and I draw and I figure out where it hits the axis, then I know that's going to be a little bit closer than that 5. So this red line, this sort of dotted line, is this equation right here. So notice I want to find this x-coordinate. I can find that x-coordinate because this is the x-axis right here. And I know that on the x-axis y is equal to 0. So kind of the last little step here in Newton's method of linearization is on this tangent line to take this guy and set it equal, this y, and set it equal to 0. So what I'm going to get is that negative 1 equals 10 times x minus 5. And, you know, there are multiple ways to do this, but what I'm going to do to solve is divide by 10 first. These cancel. That gives me negative 1 over 10 equals x minus 5. And then I'm going to add 5 to both sides. And that gives me x equals 5 minus 1 over 10. Now, if you have watched the video on differentials, this is actually the exact operation that I did with that. And I get 5 minus 0.1, which is 4.9. And once again, that actually turns out to be really, really close to the square root of 24 if you plug it in your calculator. That's all.